Okay, so for question 1, what we want to do is we want to find the total force on charge 3, which is the charge up in the top right corner of this square of charges shown here. And we're told that Q is 2.4 microcoulombs. So you can see the charges are numbered 1, 2, 3, 4, and they're in multiples of that charge Q. We have a square where each side is 33 centimeters. So that's 0.33 meters. Convert everything to meters. And we want to find the net force on the charge in the top right. So let's first of all draw the vectors. So let me do some color coding. So I'm going to make Q1 black. Q2 will make red. Q3 is green. And Q4 is blue. All right. So draw the vectors. So first the force between 1 and 3. So I've got charge 1 is positive. Charge 3 is negative. So they're going to be attracted to each other. And so the direction of the force, let me use a green arrow. Charge 1 is black, so I'm going to use a black arrow for that. The force is going to be attractive along the direction joining them. So that's F13. Okay, how about 1 and 2? So now I've got a negative charge, between 3 and 2. Two negative charges. Q2 is negative, Q3 is negative, so the force is going to be repulsive. So Q3 is going to get pushed away from Q2 and along the direction joining them, so that's directly horizontal. So that's F23. And then let's see, last one is 3 and 4. I've got two negatives, so again it's going to be repulsive. And my color is going to be blue this time. So I'm going to do the force between 4 and 3 is going to be directly straight up. All right, so I've got my numbers. Now I need to find, I've got my arrows. Sorry, now I need to find my numbers. So remember Coulomb's law. Let me write it over here on the left. Force is equal to K Q1 Q2 over R squared. And I need to find this in terms of just positive numbers. So I'm going to take the magnitudes of the vectors and I need the number for the direction in between them. So let's first calculate what the size of the charges are because it's in terms of the multiples of Q. So Q1, it says, is equal to plus Q, where Q is 2.4 microcoulombs, so it's just going to be plus 2.4 micro is 10 to the minus 6. Q2 is minus 2 times Q. So if I calculate that, I get minus 4.8 times 10 to the minus 6 coulombs. Q3 is minus 3Q. So that's minus 7.2 times 10 to the minus 6 coulombs. And Q4 is minus 4Q, so that's minus 9.6, sorry. It's minus 4Q minus 9.6 times 10 to the minus 4 coulombs, minus 6 coulombs. All right, so now I've got all my numbers and I want to find the magnitude. So the force between, now I need to find the magnitude of force between 1 and 3. So let me go to black. Force between 1 and 3 is going to be K Q1 Q3 over the distance between 1 and 3 squared. So that's going to be K, 9 times 10 to the 9. And I'm going to put, remember, the absolute value. I'm going to ignore the signs of the charges. So Q1, 2.4 times 10 to the minus 6. Q3, I'm going to ignore the signs. I'm going to make it positive 7.2 times 10 to the minus 6. And then at the bottom, I need to have the distance between 1 and 3. So 1 is at the bottom, 2 is at the top, on opposite corners of this square. So it's going to be that diagonal distance is the distance between those two charges. So I've got each side is 33 centimeters long. So if I let me draw it up over on the top, right over here. So I've got each side is 0.33 meters. So the diagonal, I'm going to use Pythagoras, x squared plus y squared. So it's going to be square root of 0.33 squared plus 0.33 squared. So that's going to be just the root of 2 times 0.33 squared. Put in my calculator, I get 0.467 meters. Okay, so on the bottom here, I'm going to put 0.467 squared. And if I put that in my calculator, I get 0.713 newtons. Okay, so it's 0.713 newtons, and the direction of it is along the diagonal of the triangle. All right, so now I want the force between 2 and 3. So let me do my color coding. I'll switch to red. F23 is going to be K, Q2, Q3, and again, I'm going to just take the size of them, divided by R23 squared. So K is always 9 times 10 to the 9. Q2, and again, I'm going to drop the sign, 4.8 times 10 to the minus 6 coulombs. Q3, 7.2 times 10 to the minus 6 coulombs. And then the distance between 2 and 3 is just the distance of one side of the triangle. So that's just going to be 0.33. And plug all those numbers in, I get 2.86 newtons. All right, so the last one is force between 4 and 3. So it's K, Q4, Q3 over the distance between 4 and 3 squared. So again, K, 9 times 10 to the 9. Q4 is 9.6 times 10 to the minus 6. Q3, 7.2 times 10 to the minus 6. And what's the distance between them? Well, the distance between them is just, sorry, not that side, the distance of one side of the triangle, sorry, the square again. So it's 0.33 squared. So it's 5.71 newtons. So I've got all my 3 vectors. Next thing is to find the magnitudes, find the components, and add them together. All right, so let me draw a little picture over here of what we have. So we've got 3 vectors. I've got force 4.3. So I've got 5.71 newtons going directly straight up. I've got force 1.3. And let me draw that more to scale. It's a short little vector going in this direction, so that's got 0.713 newtons going that way. And then I have F23 which is in like the 2.86 going that way. So what I need to do is break all those vectors into components and add them together, and then find the magnitude and direction. So let me do my normal thing of making up my table. I'm going to scroll this up a bit. All right, so I'm going to make a table where I'm going to put in the x and y components of those vectors. So I got F13, F23, and F43. I need to find their x and y components. So let's start off with the 2 easy ones. The 2 easy ones are the one that's going straight up, F43. So if it's going straight up, it has 0 in the x direction, and everything is in the plus y direction. So I'm going to put plus 5.71 newtons there. All right, the other easy one is F23. F23 is all in the plus x direction. So I've got 2.86 in the x direction and 0 in the y direction. And then for F13, I'm going to have to break that one into components. So let me put on a dashed line. I need to make, let me make a bigger picture here. So there's my F13 going down like this. What's the angle? Well, the diagonal of a triangle, sort of a square, I keep saying triangle, is at 45 degrees. So if I want to find my X and Y components, let me draw them on different colors here. All right, so this is my Y component, that's my X component. The Y side is opposite, so that's going to be sine. The X side is adjacent, it's touching that angle, so that's going to be the cosine. All right, so this is going to be the length of the vector, 0.713 cosine of 45. And the y is going to be 0.713 sine of 45. And I need to look, and I need to see I'm in quadrant 3. So my x component is going to be negative, and my y component is going to be negative because I'm going backwards and I'm going down. So they're going to be negative. All right, so I'm going to put in all my numbers and add them together. So the force total in the x direction is just going to be the sum of all these. So minus 0.713 cos 45 plus 2.86 plus 0. So I'm going to get 2.36 newtons when I put all that together. Total in the y direction, I'm going to add up down my y column. So I'm going to get minus 0.713 sine of 45 plus 0 plus 5.71, and I get a total number of 5.21 newtons. All right, so now I'm going to draw a picture of it. So it's always important at the end to draw a picture of what you've got. So let me make an x and y axis and sketch what I got. So I've got 2.36 in the x direction. Let me put on some ticks here. So I'm going to 2.36 in the x direction, and then I'm going to go up 5.21. All right, so I've got something that looks like this. So I know I'm in quadrant 1. So I want to find the magnitude, the length of this vector. To find the magnitude of the total force, just use Pythagoras, x squared plus y squared, so 2.36 squared plus 5.21 squared, and I get 5.72 is my length. To find the angle, I use tan, so tan of theta is y over x. So that's 5.21 divided by 2.36, and I get a number of 2.21 for my tangent. So to get my theta, I'm going to do the inverse tan of 2.21, and I get 65.6 degrees. And that angle is with respect to the plus x direction. So I look at my picture, I'm in quadrant 1. So I can just leave it like this. So it's 65.6 degrees from the plus x direction. Remember, if it were in quadrant 4, I would have said it's minus 65.6 from the x direction. If it's in quadrant 2 or 3, then you got to do some playing around with adding and subtracting to get you a total number between 0 and 180, or 0 and minus 180. Okay, so that's how you do a total force this time for 3 charges on another charge.